curious, just to get an idea of the audience, how many of you are already familiar with deep learning, computer vision, TensorFlow? Oh, which one of you do mobile development? Web development? Okay, quite a few. And work with embedded devices? Okay, good. Thank you for, I get a feel of the audience here. So why on-device machine learning? We know, you do the training, you train on you'll train in the cloud and with GPU and TPU, and then when you run inference, you also run them in powerful servers in the cloud. But there are cases that you need to prefer to run the models on device. For example, if you want to have more access to the data these days, like edge devices and mobile devices that have access to a lot of data, and if you want to have faster interaction with your models. And for example, back in 2016, I remember when I was trying to implement machine model on device, not so much of a model on device, but showcasing the machine learning capability. Back then, we will send the images and text to a REST API endpoint, and then the model will run the inference and come back with a JSON result, and then we pass the JSON on device. That was back in 2016. So, but these days you can just run your model directly on device, much faster. Another reason for running machine learning models on device is for preserving privacy. So you're not really sending the data to the cloud or leave your devices directly on your device. So to run the machine learning on device, so when my talk title is on-device machine learning with TFLite. I just want to clarify, as of today, most of these on-device mostly we're talking about inference. Okay, there's a bit of a training as well, which I will mention later. So there's some unique constraints when you do on-device machine learning. First one is that there's less compute power and then limited memory, and then also you have to consider battery consumption. So here is a brief history of TensorFlow for using the models on mobile and edge devices. In 2015, TensorFlow was open sourced, end of 2015. And then because of the constraint that I mentioned earlier, we need a framework to help you deploy the models to your mobile devices and edge devices. So TF Mobile was this one, TF Mobile. Was created for that purpose, but it was not so good. And then end of 2017, TFLite developer preview was announced, and then 2018, MLKit was announced at I/O. And then 2019, there was quite a few MLKit feature added, and then TF Mobile is deprecated, and then lots of new TFLite features added. So today, if you search for on-device machine learning, TensorFlow Mobile, you're not going to find any documentation on TF Mobile because it's deprecated. So today, TensorFlow Lite just turned 2 years old, and it's already running on more than 3 billion devices. And most of the Google mobile apps use TFLite. For example, how many of you use Google Photos? Yeah, you use Google Photos? Yeah, that definitely has on-device machine learning there. And then quite a few of the Google apps use that. And then outside of Google, there's also other companies that use on-device machine learning with TFLite. So here is a fun example of running machine learning model on device. Let's see if I can play this. So this is pretty fun. Me dancing there. I really look like a pro. Well, this model actually uses a segmentation and a postnet running on Android, real time with GPU, and it teaches people how to dance. This is a professional dancer here, and this is me, the amateur, but the app can help teach me how to dance. So this is just an example, a fun example of using machine learning on device, aside from the apps that I showed you. So earlier, I overheard some people in the audience, someone said, what is TensorFlow Lite? So can you raise your hand if you know what TensorFlow Lite is? Yes? And if you heard of TensorFlow Lite, raise your hand. Okay. All right, then you come to the right talk. I'm glad maybe I can share something new with you. So when we hear about TensorFlow, we know TensorFlow is this deep learning framework that you use to write your machine learning code to train your machine learning model. And so TensorFlow Lite is this thing that helps you to deploy your model to smaller devices and run faster, right? And when we think about TFLite, a lot of times we think about the TFLite model itself, or format itself. TFLite actually has 4 main components. The first one is the converter that allows you to convert from a regular TensorFlow model to a TFLite model, which you can run faster and smaller. And the second part is the interpreter. And the interpreter is what allows you to do the inference on device. And it's all optimized for mobile or smaller devices. And then the third component is the ops. So there are thousands of ops in TensorFlow, and in comparison, TFLite only has a couple hundred of ops. So which means if you write a TensorFlow, you train a TensorFlow model, when you try to convert, it may or may not, like you might get an error saying such and such op is not supported, right? But the trade-off is that have less ops, but we also have smaller models that runs faster. And then the fourth component is really the hardware acceleration. So today in my talk, I'm going to focus more on the first two, the converter as well as the interpreter, and how to use that. So there are 2 ways to just briefly mention how to optimize a model for on-device apps. And the first one is to reduce model size. And to reduce the model size, the TFLite model optimization toolkit includes the quantization and pruning, and both of which will help you to reduce your model size. So I have included in here, you can see that you can do post-training quantization, or you can do quantization while we're training. And then there's pruning. I included a link to the documentation. And then the second one is to speed up the inference. And this is just using Android as an example, that you can actually use the GPU to speed that up, or the Android neural networks API to speed up the inference. Now, we're going to look at what are some of the options for on-device machine learning, in particular, how to deploy your TF-like models to run inference. So if you are a Android or iOS developer, you can either, you get a converter model, you deploy it, you write your Android or iOS code and deploy there directly. Or you could use one of these things that I'm going to mention, talk more details, like MLK or MediaType or Freestyle.ai, to kind of help you to be able to deploy these mobile apps. If you're a web developer, you could use React Native, TensorFlow JS to make Android and iOS apps. And then if you work with embedded here, you can use TFLite, or there's a thing called the TF Micro as well. And the code is kind of similar, but the 2 separate code bases. TF Micro and TFLite both can be used for embedded, like for example, microcontroller, Edge TPU, Raspberry Pi, etc. So I'm going to start with the React Native. So the TensorFlow team just had an alpha release recently, a few months ago, for React Native support. You can use TensorFlow.js directly inside of React Native with WebGL acceleration and load the models in the same way as browser. So I've included a link here for you to take a look at a style transfer app, as well as the GitHub link. So for you to take a look at the TensorFlow JS native, React Native. How many of you have heard about TensorFlow JS, by the way? Okay, quite a few of you, because you know, most of the time today when we talk about TensorFlow, we're talking about writing TensorFlow in Python code. But you can also write machine learning TensorFlow code in JS or Swift as well. Just a side note. So, MLKit. How many of you heard of MLKit? Nobody? All right, that is sad. It was, you know, like I said, it was announced in 2018. The MLKit is a way to bring Google's machine learning expertise to mobile devs, meaning, you know, not everybody knows how to train a model for, say, OCR or smart reply or face detection, right? So Google has these models already trained, and it's powered by TFLite, and it hosted on Firebase. And it comes with the out-of-box, you know, these are out-of-the-box APIs up here, where this scenario would be people are more mobile devs that they don't know machine learning so much, they don't have the capability of training these models. Or you know machine learning very well, you train these models, but you don't know how to train these models together, you know, very complicated tasks and deploy to mobile, right? So in that case, MLKit is very helpful you to use these out-of-the-box based APIs. And then the second reason, scenario for using MLKit would be, for example, you hosted it on your custom model on Firebase, and then you can do a dynamic model downloads. And for example, if you have an Android app or iOS app, instead of repackaging your app and republishing to the App Store when your model changes, you can just dynamically just change your model without changing the packaging of your mobile apps. And then the second one is A/B testing, and then there's one about model compression as well, to make your model smaller as well as converting to TFLite. So here is another reason, like I said, this is an example about the object detection and tracking API, which is quite complex. Like there are two models. One is a classifier, and another one is a detector, right? But in order to do like the pre-processing, post-processing, and chain these two models together, it's quite a lot of work. I don't know who, you know, any average mobile devs or can put this together. But MLKit offer it to you as a package, right? So which is nice that you can just use their solution called object detection and tracking. I didn't include a screenshot here, but at I/O, I saw a demo. Like for example, a use case is that if you are in IKEA, you have your phone, you point your phone at a piece of furniture, it will recognize what that product is, and it will search through the product catalog and then, you know, bring up the information for you for that IKEA item. Okay, so that's object detection and tracking. So here is the Google MLKit AutoML feature that was added last year, announced at the I/O last year. So what this one is, how many of you heard about AutoML? You know, you probably already heard about AutoML, but this is actually embedded as part of the MLKit Firebase console, where imagine Android dev comes over who does not know so much about machine learning, you drag and drop a couple of cat and dogs picture into the AutoML on the Firebase console, out comes a classifier that can tell the difference between a cat and dog, and you just download the TFLite model, and then you can implement it on the mobile device. And not just a mobile device, you can put it on Edge TPU as well. So I talked about MLKit. It helps you to do these on-device solutions. Now I'm going to talk about MediaPipe. How many of you have heard about MediaPipe? None? Okay. Don't feel bad about this. So Google Research open sourced this about a year ago. I just heard about it a few weeks ago. and I think the news, there was like a news article just came out like 2 days ago about MediaPipe. I did play with it over the weekend, and it's pretty cool. Like, what's so cool about it is like when you run these models on device, I talk about like hardware acceleration, you have to run on GPU, etc., etc. Well, it's really hard sometimes to configure that or write the code. What MediaPipe is basically give you the pipeline to be able to do that easily. And look at the images I included here. So it has this is like edge detection, probably use OpenCV. And this one is object detection, and this one is hand tracking, multiple hand tracking, which is quite impressive there. And then this is face tracking. For the other, ML Kit or some other framework, or you can implement it yourself, like face tracking, etc., etc. But the performance part is really hard to make it run really fast. So I find this is pretty impressive with the MediaPipe. And we're pretty lucky. There are actually 2 talks on MediaPipe. Tomorrow at this conference at 1, I think it's at 1 p.m. before 6. There's this talk called the Building Real-Time Cross-Platform Video, Audio, ML Pipelines. I believe that is actually about MediaPipe. And then the second talk is actually at Google Seattle at 5 p.m. by Mignon there, which is their product manager for MediaPipe. And now I'm going to talk about Fritz.ai. How many of you heard about Fritz.ai? I suspect none of you. If you're a mobile dev, you might have heard about them because they basically try to make mobile machine learning super easy. Later on, I'm going to walk through an end-to-end example, very simple machine learning example, however, end-to-end example. You're going to see how many steps for me just to implement a MNIST, digit recognizer, right? But imagine if you want to do something like hair segmentation, much more complex. But Fritz.ai make it really, really simple, and they have not just a out-of-the-box solution like ML Kit. They also have analytics and custom model hosting, perf monitoring, etc., etc. So now I'm going to talk about the end-to-end, from model training to inference, but focusing more on the on-device machine learning part. Okay. TensorFlow 2.0. So typically your pipeline is you have the data there, you do your model, define the model, and you have a model, save the model, or carousel model. So TensorFlow 2.0 really standardized the process by having to save the model. Because in the past, it would be you write the code with low-level TensorFlow, you save as a .pb, you have to have a frozen graph, and then before you convert, etc., etc. So the conversion part has got much easier. We really standardized using tf.carousel, writing the model training code, and then standardizing on saving here. Now, when you deploy for inference, you can deploy to cloud, web, mobile, edge devices, etc., etc. So, today my talk is focusing on the mobile and edge devices part. And here's how you will get the data. Given that most of you raised your hand about deep learning, I'm not going to go through some of the links for beginners, but I do want to point out if you don't know about the Google Data Set search tool, give it a try. I think it just came out in the beta, got launched. And then here's TensorFlow 2.0 TFDS. How many of you heard about this? TensorFlow datasets. No? You want? Okay. So don't mix this up with the tf.data.dataset API. I'm actually talking about data sets as you can import a TFDS. So basically, say if you're training, MS Coco or the face select 8, these are huge data sets, right? For you to try to download the data, put it somewhere. So TFDS actually has all of them there. The image, speech, and audio, a bunch of this data there. All you have to do is 2 lines of code. You can already download the data, and it's already in the tf.data.dataset format, ready for you to do your machine learning training. So it's pretty neat, or you can collect your own data. And then the second one is models. So I'm going to talk about where to get your models. I know you are familiar with deep learning, you can train your own models, However, sometimes you might just want to download a model to use right away, or you want a pre-trained model to transfer learning, retrain, etc. So I have included a link here you can download. Since my talk is about on-device machine learning, the link I give you is the TFLite model, hosted models, and you can see a whole slew of like mobile NAT v2 quantize and different variations there. And with transfer learning, you can use the TF Hub for easier transfer learning, but TF Hub these days is not just for transfer learning anymore. So give it a try. If you go on TF Hub, TensorFlow tfhub.dev, you just type in the word TFLite, you'll see all the TensorFlow Lite models showing up there. You click on one model, it will actually show you what that model is and snippets of maybe Java code, how to implement it, etc. So it's pretty neat with TF Hub. Or you can train your model from the scratch. That's what I'm going to talk about here, but not recommended. Then you save your model. As I mentioned earlier, TensorFlow 2.0 really standardized on using that saved model for saving. And then you deploy. If it's to mobile and edge devices, you do need to do a conversion, and then you will deploy, and then you will use that TFLite model to run the inference. So now I went through that end-to-end example in general. Now I'm going to talk about end-to-end for Android. I know, here we don't have Android devs here, but it's kind of interesting to understand the process if you're interested in on-device machine learning. So the first one is you write your model with tf.keras. So how many of you actually use keras? How many of you write the code with PyTorch? TensorFlow low level, like anything TF dot, blah, blah, blah. Okay, so a lot of you use keras. And I call it tf.keras. With TensorFlow 2.0, there's actually, inside of TensorFlow there is keras, right? So the actual independent keras.io is no longer having major releases anymore. So with tf.keras, there's 3 ways of defining a model. You can use sequential or functional, or you can use model subclassing. The model subclassing is very similar to PyTorch if you're familiar with PyTorch. It has a lot of flexibility for you when you define your model architecture and doing training, etc. And then the second step is actually to convert to TFLite, and you can convert through either Python code or command line, which I will go over later. And then the third one is to run Android. There's all these steps here, right? I would imagine probably with iOS, perhaps similar. So if you have an MNIST data set here, we have the data, and then I have a collab that you can actually train the model here. And typically this is your network architecture here, right? After that, you can inspect your model with the model.summary here. You can also inspect your model architecture with TensorFlow or with Netron. So how many of you heard of this open source tool called the Netron? Nobody? Okay. So the Netron is pretty neat. You just drag and drop your .pb, .tflite, any kind of model file into that GUI. You will see a visualized your model architecture here. Now there's TensorFlow Lite team is also working on a TFLite tool to allow you to give the model metadata to people. So that allows you to inspect the model and actually also allow you to modify the metadata. So this is not yet launched, the metadata. So model saving, I already mentioned earlier about save the model. But I also want to point out, at the moment, at least myself, I find it slightly confusing. You can save, if you train with tf.keras, you can save to a saved model. You can also save to a keras model. So I just want to point out when to use what. The save the model, the save the model one, if you want to share pre-trained model on TF Hub, for example, you definitely need to have a save the model format. Or if you already know your deploy target, or when I say deploy target, well, you know, whether it's Android, iOS, Edge TPU, or Raspberry Pi, if you don't know the deploy target, it's best to save it in save the model so that perhaps there's two people. One is person is training the model, saving the model, and then give it to an engineer to deploy, right? In that case, save the model is much more portable. But if you are doing training the model and deploying the model, you know, like I know how to train a model and I know how to deploy it, right? And I'm writing the code in tf.keras, I could directly do the conversion from a keras model to TFLite. Anyway, when in doubt, just stick with save the model. So, as I mentioned earlier, there are two options for converting to TFLite. One is via command line, another one is via Python code, and it is recommended, this is recommended, use Python code. Okay, but sometimes you have no choice, you have to use command line. Okay, can you think of a scenario you have to use command line? So one scenario is you got this, some model, give it to you, you need to convert, right? So you just need to do it through the command line. One thing I want to point out is if you look at the converter code, it has changed a lot through the end of 1.x before we go to 2. Is that some of the tutorials you see online, you will see that they have this code to save to a keras model first, then do the conversion. But actually with 2.0, you don't have to do the saving to keras model part. You just define your model and train your model. You have that model object. And then you can do directly use the from keras model method and feed in that model to do the conversion. And the conversion itself, you know, just a few lines of code. As long so long you don't run into errors, the conversion itself is pretty trivial. The code. So here, this step is actually a validation. So this, after you do a conversion from whether save the model or a keras model to a TFLite model, before you deploy to your mobile and edge devices, highly recommend you write this Python code to actually validate that your model is still working after the conversion. It is still as good as before the conversion. I mean, trust me, you would think the converter will not make a mistake, but it does. Sometimes your regular trained model is working after you convert. All of a sudden, you deploy to Android or iOS, it's not working quite so well. So it's very good to validate it first. And just in my opinion, I feel like there's a lot of boilerplate code try to validate. You know, for me, I kind of wish the converter itself does that for me. You know, it converts, it should validate for me. Anyway, I think it's on my wish list. Maybe one day it will be implemented. So TFLite on Android, I will fast through some of the slides. I will go over very, very fast. But this is the summaries, play step by step, right? Some of the step is pretty, only applicable for Android, but some of the steps are probably applicable for other platforms as well. So I will just go over it. First one is the dependency. We put the model in the assets folder manually, manual step. And then the second step is in the input image. So I'm talking about the computer vision models here, right? Input image can come from your camera, live frames. Input image can come from your gallery, like there's already a picture taken. Or you can rely on like a third-party camera to snap a picture, or it could be a picture just embedded inside of your application. At any rate, you need to have that image, and this is pretty tedious. You have to make sure the image dimension matches what your classifier expects, like if you train a classifier. And so the dimension needs to match, so depending on what kind of network you trained or retrained. And then there's also pre-processing, like for example, in your model training, first of all, you also need to convert from bitmap to byte buffer, which is quite a pain. And you also need to normalize the pixel values. So whatever you're doing when you write your machine learning training code, you have to do the same on mobile. And you need to also convert between color and grayscale manually as well. So I want to point out some of these steps are applicable on Android, but I heard that you don't have to do it with iOS or with OML with iOS. And then you will run inference once you have this TFLite. You create an interpreter, and then you run the inference. After you run the inference, you get back a result. Now I'm talking about the simplest case of MNIST, right? Coming back with 10 array of probabilities, and then each corresponding to a digit. Then you need to pick the one with the highest probability. So for example, over here, say this is an app, I use my finger to draw a number 8, and I click on the classify button, and then the model will run the inference, and then comes back the probability, and then I will pick the one with the highest probability, which is number 8. So, very, very simple example of a digital recognizer. So why I go through this very simple example? Because even with this simple example, I mean, even if you don't do Android development, you get there's a lot of steps, right? Very tedious. How big your image is, you have to match your image, you have to match the color channel, and all the things I wish I don't have to care. Like I trained the model, I have the image, and you should just know how, right? But I have to worry about the image pre-processing, post-processing, input tensor shape and color or grayscale, etc., etc. So a little bit tedious. So imagine that was just MNIST. Imagine you want to implement something even more complicated, right? It's even harder. TFLite team has worked really hard, and these are the set of new features announced at TensorFlow World last year. And I want to talk about just a couple of them. So the first one is, for example, the new TFLite support library. And this one is for Android. And a lot of the steps I talked about convert from a bitmap to a byte buffer, etc., etc. With the support library, you don't have to worry about it. It will probably take care of some of the image resizing as well. And the second one is the model, the metadata one's not yet launched, but I mentioned it earlier about allowing you to see the metadata about your model and edit the metadata. And the third one is the repository. So I already included links, so you will see hosted TFLite models. And then this one, I find it pretty interesting, this one, model customization API. I think this will be really, really interesting for people to try out, especially for people who are not familiar with machine learning. What this is, I talked about AutoML, whether it's Google or Microsoft or other company, you feed in a couple of images and you can outcome on a model, right? So this model customization API actually allow you to just point to a folder of all your images. I think it does use transfer learning as well, and retrain a model. And what it does is I think inside of the library also does the data pre-processing as well. So you will make the model training part pretty easy over here. And then there's more examples which I'll mention. And then there's a course here on Udacity, a very nice TFLite course. Okay, so I talked about that simple MNIST digit recognizer. You can check out the example on the classifier here. And you can read about the blog post on how to do the TensorFlow Lite with the GPU enabled here. And you can also check out a PostNet example. And there are more examples like object detection, smart reply, style transfer, and a lot. And it's not just computer vision. And you can also look at some of the examples on text by Hugging Face, which is pretty neat. And on-device machine learning training is finally here. As I said, most of my examples I talk about are about running inference, but this one is actually training. Right now, it's slightly limited. It's just a classifier, You can train by taking 20 pictures for, so right now you can train maybe 4 different classes, and then you can take 20 pictures. And transfer learning on quantized mobile net v2, and at the moment is on Android only. So this is actually just came out not long ago, the on-device training itself. So now I'm going to quickly move on from talking about mobile to talk about the edge devices. And here is TensorFlow Lite for microcontrollers. I have included some documentation on Colab for you to try it out, and you can implement the model on a very small microcontroller that runs just a coin battery, can run for days. So pretty interesting for those of you who do embedded. And this one is the Coral Edge TPU. How many of you have heard about Edge TPU before? Okay, quite a few. Some of you have heard about it. So this is Google's hardware for on-device machine learning acceleration. You can go look at the website. The 2 main products, one is actually the dashboard itself. And using the dashboard itself, you just connect it with the camera module. But if you pick like the cheaper, I think it's like $70 USB stick, that one is just an accelerator, and you can connect with the Raspberry Pi and the camera module again, like here. But this one is more powerful, I believe, and it's more customizable, this one. So I have also included a link here to Colab that you can try it out. Here's just an example of running the mobile SSD model on the Coral Edge TPU. As you can see, when it's running on the TPU versus the CPU mode, and you can see this is much slower, right? And this is much faster here. All right, so here's on-device machine learning trend that I see. In 2018, Pete Warden, who is the TFLite lead, wrote a blog post called "Why the Future of Machine Learning is Tiny." So I highly recommend everybody just read that article, because I think there are many trends about machine learning, but really the trend is going small on mobile edge devices, right? And I would expect that deploying to mobile edge devices will get much easier. And TFLite is going to have many more features to make both the model conversion and also model deployment and running inference much easier. And then another thing is federated learning. That's the next trend. How many of you heard about federated learning? Okay. I didn't include it in my slide, but what that is, like, it basically, federated training is that you can do distributed training without the data leaving your device. So Google Gboard is one example. And on-device training, I showed you a very simple example of transfer learning with just 20 pictures. That's just a start. I would expect that with the devices become more powerful, we will have more scenarios of on-device training. So I have put together an awesome list of TFLite models, samples, and tutorials and learning resources on this GitHub repo. There's a lot of support from the GDE community and the TFLite team that they helped me, support me to start this, and we welcome community contributions. So if you have created any on-device machine learning examples, you have converted any models to TFLite format, etc., so feel free to go check this out, and I welcome your contribution. And actually, let me see if I can go to just show you that real quick. So here is the awesome TFLite. You can take a look at here. A lot of things I mentioned is here with the models and the model zoo and courses and learning resources here. So you can check it out later on yourself. And I'm going to go back here and finish up. So here's the link that you can check it out. Okay, so that's it for my talk, and thank you so much for coming to my talk. If you're interested in like deep learning, computer vision, TensorFlow, and on-device machine learning, please follow me on Twitter and Medium, and also GitHub. And thank you, everyone.